Hi, in this video I'm going to go over Chapter 6. Chapter 6 is mostly review for us. So Chapter 6 starts off by talking about fields um, and local variables and parameters. So we have some fields here. Fields are defined outside of any method. They're usually declared as private. You should almost always declare them as private unless you have a very good reason not to. I've declared a variable, a field of type object, a field of integer array, and a field of type string here. And just to finish up with this area, I've also declared a constant called pi, which is 3.14. And with this I can illustrate quickly the value of constants. We've already talked about this, but say I had pi used repeatedly throughout the program. If I wanted a more accurate representation of pi, I could just add the additional digits here, and wherever I've used pi in my program, it would use that new value. One change and everything in the program, every place in the program where pi is used is updated, so that's really useful. And you should definitely make use of constants going forward. It's the static and final. Static is not actually needed. We'll talk at some point exactly what that means. It means it's a class variable and not there's only one version of this variable for the entire class. No matter how many objects of the class we create, there's only one. So it makes sense to declare it as static so that each object doesn't have its own pi value. It's just that one. And the final obviously says it can't change after you've initialized it. Okay, so let's now look at let's just take a look at these. We will make an object of this. I need to supply a parameter for the constructor. And let's inspect that. And as you can see, those three objects were set to null. Now, if there had been a primitive like an int in there, I'd have 0 here. But variables that reference objects are their default value set to null until we've used new to create an object and store a reference to the object in the variable. And so let's do that. So here we'll start with x, this object x. And so remember, object is the superclass of all other objects, so we can basically stick create a new object of any type and store a reference to it in x. And so what I've done here is I've said this dot x equals hello. This dot means this object's x field, right? As opposed to this parameter x, which is a totally different critter. So we want to make sure anytime you have a parameter or a local variable with the same name as a field, if we want to reference the field, we need to preface it with this dot to say the object's x field, not the local variable. Okay, so I compile this now, and again, make a new one. Keep forgetting the parameter, and inspect that, and object x is now hello. Okay, and if it had been any other type besides a string, there would be an arrow here referencing the actual object, but strings are treated a little differently, so Java just puts the representation of the string here. Okay? The other two are still null, so let's fix that. We'll use new here to actually create a chunk of memory for this array of the chunk of memory big enough to hold 5 integers, and we'll make this string equal to 1, 2, 3, and again we'll compile, make a new one, supply the parameter this time, and hello is x. We saw that. Here's the reference to that chunk of memory where the array is stored in all zeros because it's a primitive so that all 5 cells have zeros. That's the default value. And again, another string, so instead of the arrow, it just shows us the string here. Okay? And now, so just a little bit more, just reinforcing of the fact that local variables can have the same name as fields, and you have to be careful about that. Here we're doing system out println x. Which x is that? It's the parameter x and the field x. So here's what it output. Since I'd specified 3 as the parameter when I made the object, pass that into the constructor right here. That x is outputting 3, and this dot x is outputting the hello. Now notice here I call some other method, which I've written right down here. And in this I do system out println this dot x, this dot x. So that is printing out both, in both cases, the hello. But look at, if I do this, what's it going to do? It's also going to print out hello. Hello, hello. Because there's no confusion. There's no other local variable named x, so whether I do the this.x or not, Java's not confused. It knows that I'm referencing the field, and so the field contains hello, so it just outputs hello. Okay, next up is blocks. Local variables actually exist within the block where they're created. So in this case, I created this integer variable b within this block. Blocks are defined by braces. So it actually only exists within this block. And if I try to reference it outside of the block that it's created in, look what happens. Cannot find the symbol b, because b doesn't exist. As soon as this block is finished, the b is thrown away by Java. What I've told you before is that local variables exist only as long as the method they're in is running. And that's because usually local variables are declared in the main block, the top block of the method. And so they exist throughout the method. But in this case, I've declared it in a sub-block, so it only exists in that sub-block. If I moved it up here where we normally define local variables, then Java would be perfectly happy with this because it exists in the main block and all the sub-blocks that are within the main block. Okay, so that's known as the scope of a variable, and it exists. What variables exist within the block that it's declared in, plus any blocks that are sub-blocks of that. Okay, so that's blocks and scopes of variables. Now down here to some miscellaneous stuff, but mostly related to, well, a number of things. So first, integer division, right? If both operands are integers, then the result of the division will be an integer or a whole number. So in this case, this returns how many times 2 goes evenly into 3. Actually, let's compile this and run this so we have this right next to us while we do it. It'll be quicker. Okay, cool. So 2 goes into 3 once, and that's what we return here. In this case, one of the operands is a double, so it does normal division, so we get 1.5. In this case, we're doing modular division, so we get the remainder. So 5 goes into 3 0 times, and 3 is left over. And then down here, we're forcing, by using the cast to double, we're forcing the 3 to be a double. And that happens, that takes precedence over the division, so that happens first. So that returns a division, a normal division, 0.6. In this case, The modulus operator has the same precedence as multiplication and division, so it going left to right, it happens first. So the 3, we get 3 again from that, and we multiply that by 1 times 1.2. And here's something interesting, right? What is this, right? We should be getting 3.6. This just gives you an indication of how real numbers in computers have some issues with them, right? Sometimes you cannot store in a digital representation of a real number the exact number, and that's reflected here. We're very, very close to 3.6, but it's not exactly 3.6. So just something to be aware of. Next, quick discussion of review of the plus plus. If it's used after the variable, then this first will return the current value of the variable and then do the increment. So that's why this outputs 1. In the post location after the variable returns 1. Even though after this line is done, test is equal to 2. Down here I set test back equal to 1. And then on the next line I used a pre-location, put it before. And this will actually return, we'll do the increment the variable and then return the value. So that returns 2, as you might have expected the first one would do, but it didn't. So just use plus plus or minus minus carefully, because they can be a little tricky. Okay, anytime you want to convert a primitive to a to a string, you just need to add it to a string, in this case the empty string, and that becomes a string. So you already know this, I think, can be useful. And finally, most objects should have a toString method. You wrote a toString method for the card class. And as having done that, you know that exactly what toString returns is determined by the programmer of the class. So the array class has a toString method, and it returns this, right? What's that? I'm not sure. It's probably the address in memory where the array block of memory holding the array is located. Doesn't matter, but just be aware that you can't use a toString method for somebody else's class and just assume it's going to print out something. You have to check what it actually returns, how it represents the object as a string. Okay, and that is a super quick review of Chapter 6.